Hi, everyone. As always, welcome to the call. Some context here. These core devs are always for core contributors to present the latest protocol updates and discuss upcoming features and changes with community members like you. So thank you for joining. While there is time for Q&A after each topic, you're highly encouraged to continue the conversations over the forums, Discord, and GitHub. Everything is out in the open, and we do want your feedback. So I'm going to paste the link to the Graphs ecosystem calendar in the chat and show notes so you can subscribe and for future calls. We also have all of these recordings uploaded to YouTube, so be sure to subscribe if you'd like and check all previous recordings. Lastly, I'm going to also share a link here to our forum where we are posting general updates from the different core development teams. I highly encourage you to follow those as well. And yes, we're currently using the forum. We might be using another platform very soon, but I'm going to drop a link to the forum for now. So going on to the agenda, we have quite a few topics. We're going to be quick with the GIPs. Pablo is on the call. I think I've seen him already. Thanks for joining, Pablo. We're going to do a quick update on all of these. And then, as mentioned before, yes, this call is heavily focused on the SQL data service. So we have a bunch of people joining. Tumai from Semiotic. Oops, sorry about that. We have Tumai from Semiotic talking about why we're doing SQL. We're going to go through the recent experiments with ClickHouse and some benchmarks that Semiotic has been sharing. And also Vincent from Masari will be introducing you all to DBT, a new technology or something we've been exploring that might be part of this Substreams-based SQL sort of data service. And so Vincent will be doing a quick demo too and talking about this. Lastly, StreamingFast is something very interesting on the Substreams-based SQL data service. And there's a new tutorial we can also share, posted on their website for now. And so yeah, that's a lot of things to cover. So I'm gonna go straight into the start right away with Pablo, so we don't spend too much time here. Oh, but before we do that, sorry, Nick, you wanted to say something about the AMA? Is that correct?
Yeah, can you hear me?
Yes, I can.
I just wanted to let everybody know that there's an AMA going on right now in the Graph Reddit with all the core dev teams. So members of the core dev teams have come to answer questions about New Era. And there's been some great questions, so you can scroll through it and read it. And there's a couple more that dropped today. And today's the last day. So I'd love to see anybody over there. And it's a great time to engage with core devs.
Perfect. Thank you, Nick. Thank you so much. All right, let's get started. Pablo, you're up.
Hey, folks. All right, thanks for having me. I am going to share my screen just to show some of the council proposals related to these GIPs. So there's a lot of things going on. I'm going to do a very quick update on the things that are kind of moving forward through the pipeline. First, about L2 rewards. This has actually already happened. We have increased the rewards on Arbitrum to 95% of the total. This happened on Monday, and we have the proposal up just for the council to sort of officially ratify the action that they took. So this is up, this is running. Rewards are 95%, and then the next step would be 100%, which would require mostly, so in JP 52, we had proposed it should be at least 1 month from now, but also that at least 90% of the subgraphs that are active and have queries have moved over to L2. I think we can revisit that 90% number just to make sure that no one is left behind on L1, so to speak. But it seems we are moving towards the point where we don't need the mainnet graph network anymore. So yeah, hopefully Arbitrum keeps working as well as it has. And over time, more people move over to L2, and then we can get to that point, which will, of course, require another council transaction and approval. Then moving on to these two GIPs, so GIP 41 and GIP 59, they're actually two different, but they're actually two different GIPs. They are unrelated, but we had bundled them into a single snapshot council proposal. And the previous time the vote expired before the council members were able to vote, so we're just putting it up again. And this was discussed with the council on the last council meeting this week. So there is a consensus from the council on moving forward with this. We are expecting a positive vote here, and then the team I'm part of, that is the general smart contracts team, will execute the final test and deployment plan to get these two to main as well, Arbitrum 1. And the idea here is, one is just an incremental update into the dispute manager contract, just to store the dispute status whenever a dispute happens, when an indexer is either slashed or not slashed because of a bad query or POI. And we're just storing that status on chain, which means that on chain you can now validate whether a POI has been disputed or not, and whether a dispute was successful or not. And the other one is about removing the owner tax. That is an additional amount of GRT that at this time subgraph owners need to pay whenever they want to upgrade the subgraph to a new version. So this would remove that owner tax. There would still be a curation tax. So there would still be something that removes some tokens from the curation pool whenever there is an upgrade, whenever a new subgraph is made and the signal is moved from one to the other. Yeah, there wouldn't be this additional burden on the subgraph owner whenever that upgrade happens. So also expecting a positive vote here, because the council has at least verbally expressed their approval of this. And we're also going to move forward with the testing and deployment plan soon. Similarly, this was also discussed with the council this week. There's been a bit of back and forth in the past, but this is a GIP that is GIP 56 that is about removing a very specific restriction that we have in the staking contract for who can inject payments of query fees into the protocol. Because currently that is like an allow list of gateways that can do it, and this would allow anyone, basically any address, to inject fees there, and therefore anybody could in theory be an indexer if they are able to set up all of the a gateway if they're able to set up all of the related infrastructure for that. This would remove that restriction, and it's another step towards full permissionlessness, let's say. There used to be a few security concerns with doing this, and we've done a few iterations of the changes here to make sure this is secure. It doesn't introduce any additional risks. So we've audited these recent changes, and at this point we're confident that we can deploy them, and the council has also verbally agreed with moving forward with this, which is why we have the snapshot vote now. And we're going to work through the final test and deployment plan as well. And then finally, there is another GIP that is a bit more recent, that is GIP 62, which we have also now discussed with the council, and the council has approved moving forward with this informally, and this is again the snapshot to formally approve that, where there is a delegation parameters cooldown field that indexers set, where they say they kind of block themselves from changing the indexing rewards cut and the query cut for a certain amount of time. And this hasn't been used in a long time for a few reasons, but also there was a particular issue where a UI bug caused an indexer to get locked for longer than they intended to. So this would remove, it wouldn't block this particular indexer, but it would also remove an unused feature. And then the council has also recommended that we look at things like the delegation tax and the way indexing rewards cuts and query fee cuts are established, or defined. So we're gonna keep researching on that, but in the meantime, we can move forward with this change, which is nice because we're simplifying the protocol a little bit. Changes that remove lines of code make me feel good as a smart contracts engineer, because less complexity always means reducing a little bit of risk, attack surface, and so on. Things that could go wrong, like this UI bug that I mentioned. So yeah, we're also moving forward with this, hopefully relatively soon. So yeah, I can't provide specific timelines on when we would execute the test and deployment plans. Those things tend to take a bit of time. So hopefully these four changes that I mentioned will be part of the protocol relatively soon. And I think that's the update I had. Oh, well, the other thing is we discussed GIP 61 with the council that had to do with some improvements to the GIP process and some like simplification in the GIP process that you post. If you want, you can take a look at the forum for the detail. There was some feedback from the council. We're going to iterate a little bit more on this before putting up a snapshot vote. But hopefully we'll also have council like approval of this change in the process that should make things a bit clearer and simpler. And it also reflects a few things that have already been happening in practice. So yeah, more updates on that hopefully soon. But that's what I have for now. So thank you.
Thank you, Pablo. I just wanted to mention also, I mentioned 58, GIP 58, replacing bonding curves with indexing fees in the beginning. We don't have Justin or Howard on the call, but there will be an update on the forum very soon. And related, the GIP 63, that is the optimizing query fees sent to indexers, I'm going to post links, will likely be withdrawn. So just sharing this here, we'll have more details on the forum very, very soon. So stay tuned. All right. Thanks again, Pablo. And now, yes, Tumai, you were ready before. Go for it. I hope you still have the energy. Go for it.
Yeah, thank you. Let me share my screen. Okay. So I'm Tumai from Semiotic. Actually, I will try to explain why we want to have an SQL stack built over Graph. Basically, our aim is try to provide an analytical solution with the Graph. So currently, our target is not overlapping with the GraphQL because the GraphQL usually indicates that the developer is knowing what they want initially. But the analytical part is usually depends on the business requirements, and they are usually like used by data scientists or other business marketers to research stuff. So it's not easy to identify the structure of the data in the beginning. So basically, we are good with the GraphQL strengths. As you know, developers can build custom API endpoints. They don't need to maintain the backend because there's already a GraphQL endpoint. And as I explained, it's great for fixed queries. How we imagine the Graph will enable the SQL queries. We build a stack over it, and it's an ETL. So Firehose is extracting the data from the blockchain into flat files, and with Substreams, we can shape the data into events or traces and push them into ClickHouse. And with the transformation inside the ClickHouse, we provide analytical data to be consumed by the SQL. So this analytical data is usually is like we call OLAP, which is like a grouping, like summations, averages, and different type of transformations, which are not easily available to on demand to GraphQL. So we create a ClickHouse solution and then compare it with the standard Postgres solution for this type of requirement. So basically, the difference between two systems is Postgres is a transactional processing database, online transactional database. So basically, every record is recorded inside the rows. And so if you need any data, like an aggregation, you need to crunch or digest these data from each row. But when you compare it with the OLAP, online article processing data, you are always going to the columnar type databases, which are very, very specialized for this type of queries. So you don't need to crunch all the data in the rows. You just use let's say, transform the data only from the columns which are sequential, which speeds up the things really, really much. So after some transformations, after some tests, we see that these results. So basically, even inserting without the transactions, because all up this, for example, ClickHouse do not support transactional inserts, but it also speeds up the insert of events and everything. So basically, these are the results, and also it has a very high compression ratio due to the structure of the columnar databases. And from the query side, these are questions, but actually they map to SQL. We test the same thing with Postgres having lots of indexes optimized for the queries, and ClickHouse without any optimization. The results are nearly 10x faster, 10 times faster. And sometimes we couldn't receive the result. That's like what is the most popular DAX. We receive timeouts, but instead of timeouts, ClickHouse easily answer these questions. By the way, ClickHouse is not only one solution. There are other new database solutions emerging with the same idea for analytical processing of the data and capability of crunching data online. So what we expect to come next is we think that with enabling the SQL in the graph ecosystem, the analytics market research, dashboards, block explorers, or even anti-fraud researchers can come to us and they can use the ClickHouse or another database, OLAP database, for these queries. We build a project called Agency. It turns into a little bit product. We try to generate and generalize database search with LLM support. So I would like to show you the video. So this is one of the results of this stack. So let me start it. So users can ask anything related to Ethereum DEXs. So it turns into a SQL with the LLM, and the result will be ready in seconds. So also this allows us to query, as I explained, query on demand.
So maybe you can speak to how this data was indexed in the first place. Was it the Substreams based indexing, like all of the events on these smart contracts and then storing it to ClickHouse? Was that?
Okay, yeah, I can go into details. So basically, we have a workflow. We believe that we shouldn't be doing any transformation while we are collecting the data because it's really important from the analytics side. So we just collect the events, or if it's required, for example, in the case of Uniswap X, if it's required, we collect the traces also to be able to extract this data. But we don't do transformations inside the substream. So basically, we do the transformation inside the ClickHouse, which is something like a live transformation, which is usually people call it materialized views. But it's not really fitting well because it's not something we just have been materializing from one resource. For example, we have been materializing DEX information, DEX swap information from multiple sources like Uniswap, KyberSwap, SushiSwap, also Uniswap v2, v3. So basically, it's something like you create a DBT type data transformation inside the ClickHouse, which is relatively, I believe, faster than anything for the moment. Let me give you one example. To be able to crunch this data, full Uniswap data, which means like it includes more than 80 full factories like Uniswap v3. So to be able to crash this data, I mean, we spent only 2 hours. In 2 hours, it can crunch it into the materialized view, and actually it continues to crunch it. I mean, it's, as I explained, it's online. If any record came into events, it will still continue to crunch into these aggregations and everything. ClickHouse also has some tricks. I didn't write it here, but it's a total detail. It helps us to expand our queries easily. Like one of them is projections. So you can easily create aggregations beforehand. The user queries them like a monthly or annually data based on the groups. And user will just send the standard query to the table. But if they send an aggregation, it will be automatically rewritten by the database, which is called SQL. So it rewrites it and use the aggregations on that table. All this stuff is totally automatic. We don't need to sync it again and again.
Yeah. Yep.
Okay.
Very cool. Thanks, Sumay. Is that your last slide? I'm not sure.
I think it's our last slide. Yes.
All right. Perfect. Thanks. I think it's a great segue to what Vincent from Masari. Oh, we have the timeline here. Okay.
Yeah, we have the timeline here. Okay, sorry, I forgot that. So basically, we crashed this data, event data with Substreams is working for the moment. So we are testing now to deploy this substream, to Pinex, so that we won't be using our own infrastructure. So it can be deployable to any graph indexer in the future. Yeah, in the future, we expect to integrate the SQL with the gateway and billing so that users will easily access this data.
Yeah,
that's my last slide. Yeah.
Perfect. Thank you, Tumay. What you have here, like the DBTs, I think that's a perfect segue to Masari. I think Vincent will be going through DBT and the materialized views you just mentioned as well. And then at the end, StreamingFast will also have a full demo, which is pretty cool. So by the end of the call, we should understand the whole stack, and then we can do some Q&A. All right, thanks, Vincent. Yeah, I can see your screen.
Perfect. Should I start?
Go for it.
Yeah. All right. Thanks so much, Tumay, for the introduction on the SQL services. Like we love at Masari, we love SQL as well. We do a lot of analytics stuff. Just doing massive like transformations, aggregations on that data. So in the SQL world, or the SQL developer world, it's actually pretty different from the what you would consider as a typical programming language, like I don't know, C++, TypeScript, assembly scripts, Rust, where it's like essentially built for engineers by engineers. There is a lot of developer tooling. There is a lot of great compilers, IDE, testing framework, and so on. But in the SQL land, because most of the people that use SQL are like data analysts or kind of people on the finance accounting team who may not come from an engineering background. So the tool on SQL side of the world is actually pretty lacking, and it's been lacking for a long time until fairly recently. There's this company called Fishbone Analytics that developed this thing called DBT or data build tool that got really popular kind of in the past 2-3 years that are essentially kind of the IDE / compiler / I don't know, testing framework, developing framework for SQL. So it is really built like it's a super powerful tool built for SQL developers. It's kind of like taking, I don't know, SQL to the next level. And it's almost like I don't know, like buffet style, or I don't know, like a Swiss knife toolbox, where it does a lot of different things for you. So it makes development easier, it makes testing, documentation, visualization, lineage, as well as deployment easier. So you can kind of see in this diagram here that on one side of the world you have the raw data, and then there is like a lot of tool suites that's offered within DBT, like essentially everything here, and DBT integrates with different data platforms. For example, like you have Snowflake, BigQuery, you have Databricks, you have ClickHouse and Postgres that we are using, and then on the other hand, you have on the other side, you get the really nice formatted, aggregated, transformed data set that you can in turn pump into the next stage of the data pipeline. So I want to show you an example of what that looks like. There's a lot of like conceptual stuff here. I want to kind of bring it more concrete. And as you can see, so this is a snippet, a code snippet of our like Uniswap kind of DBT model. So a DBT program is called a DBT model in their world. It's essentially a set of SQL queries with kind of some custom DBT magic. So you can see the bulk of it, right? Starting from like line 14. It's very familiar, right? These are mostly SQL code with some like modified stuff, and these are basically references. These are called macros in DBT. It's very similar to like macros in like C++, if you're familiar with that. It's kind of the pre-compilation step where you can essentially use variables or references to other places, which makes the whole development process a lot easier. And then at the top here, so these are also macros that kind of like define some of the variables that I've been using. And then you can put in a set of like configurations, for example, like, hey, how do I want to like materialize this table, right? Like, what do I want to do with the output? Is it materialized? Is it a view? And so on. You have a different number of options here. It does. Oh, huh. Can you guys see the image or no?
Not right now. We lost it.
Okay. I have no idea what happened. Okay, there's supposed to be an image here, but it basically shows like the data lineage between different data models. It's the thing that's really nice about DBT is that it allows you to like factor a giant SQL query into like many smaller data models that are like interrelated. It's kind of like Substreams, where you have different modules that are dependent on each other. You can reuse them. You can kind of save the output and then just like cache it and you consume by the downstream modules. And the tool DBT natively it offers this capability for you to visualize the interconnectivity between different modules, or what they call DBT models. So there's supposed to be a chart that shows that, but never mind. So the other nice thing about DBT is it is completely open source. It has a really big kind of developer ecosystem in the Web2 world, so this is the core library, where you can see they have like 8,000 stars, you have like 1,400 forks and so on. And then there's a lot of like a whole suite of developer resource that you can just find on the internet. For example, if you go to dbt.com, getdbt.com, they have a whole course on how to use DBT. So like courses.getdbt.com, and to learn, you can just go through that. Jinja templating is another powerful and also like a very popular tool suite that's embedded within DBT. It's very similar to like the mustache framework that we use in subgraphs. It's very much kind of the same idea. It's all templating, but it's native to DBT. Yeah, that's all I have.
All right, very cool, Vincent. Do we have questions before we move on? I think the last presentation will be pretty nice to close this loop, figuring out how this actually works with Substreams as well. StreamingFast team has also a demo, but let's pause a bit and see if there are any questions. I don't see anyone writing in the chat. Yeah, all right, let's go. Matthew, do you want to start with or is it Steph that's coming? That should be next. Oh, sorry, you couldn't speak. Matthew, can you try now? Or you'll start. Perfect. No, you should be able to now. There you go.
Perfect.
Oh, you're all there. Hi.
We're all there, so we have the whole team.
Wow. It's a Substreams party. It's gonna be fun. Let's go. Okay, we can see your screen.
Perfect. So let me just take that to full screen. 1 second. All right. So yeah, now that we had great presentations showing how SQL data services make sense and how they can enable a lot more use cases, we're going to show a little bit more the behind the scene. What does the backend look like? And this comes from us talking to a lot of developers, people that are leveraging the technologies that we're all developing with the graph, and some questions that they raise either about Substream, Subgraph, but also competing solutions. So we have kind of two sides of the market: people that want real-time API access. So they're scaling their front end and their applications. Those people tell us that like they spend a lot of time deploying, maintaining their infrastructure, don't want to do that. We've heard that the learning curve for Substreams can be steep. So learning Rust, having to start on a new language, it might be hard understanding the framework. People, once they use Substreams, they fall in love with the technology, with the high performance, but sometimes it might take them a little bit of time to get started. And also that like it can be hard to join on-chain and off-chain data. And on the analytics side, currently on the market, there's no great real-time solutions. And the analytics stacks like Dune are hosted on a proprietary platform. So yes, the spellbooks of Dune and the SQL is available, is open source, but you write that open source code, you can share it with the world, but everyone has to run it on a single platform. You can't port that, you can't deploy that yourself. So we wanted to come up with a solution to this. And the idea is to build deployable units. So having a way of deploying an entire infra, an entire backend that's going to be indexing the data, serving it, without having to worry too much about how will this scale, how will this be hosted, how can I run this thing. So the beginning of the stack is what you know pretty well: Firehose, Substreams, then using the SQL sync to drop the data into Postgres or ClickHouse. Obviously, we could support dozens of databases here. Like for the scope of where we are today, we've really focused on Postgres and ClickHouse. Then leveraging dbt for data transformation. So if you prefer to use dbt and SQL to transform the data rather than Substreams, that's a new option that we're adding here. And then we're exposing that data either through PostgreSQL, so you have GraphQL or REST API that sits on top of your database, and so your front end can directly query this data, or you get a direct SQL access. And so in that case, you can plug your analytics tool. Like Semiotic demoed, you can have an LLM that generate SQL queries and that gets access to the database. You like your app can have direct SQL access. And so everything that's in this box, you can deploy it in one click. You don't have a setup required, and you have like potentially no code or low code that's required to write, because you can leverage existing substreams we have code gen modules that can extract data from contracts. And so you just give it a contract and it will extract events from there. So you don't have to write anything yourself. You don't have to get your hands into Rust, or you can write it in SQL, which is a lot more accessible. Almost every dev has done some SQL at some point for an application. So now you can have your backend completely managed for you and hosted on the network. And so this can have, obviously this is very composable. This can have multiple flavors. So the setup of Semiotic looks like this. They use only ClickHouse for the data and then query the data with SQL. So with this, you have the advantage of you can do batch transformations with DBT. You can even have real-time transformation with DBT if you create views only. So if you're improve the performance of ClickHouse, if you optimize how you use ClickHouse, you could query real-time data directly. And this is compatible with existing SQL models that you might have already, or that might be open source already. And then for more of the real-time application, you just have to worry about building your front end. You configure a Postgres sink, the database, Postgres file that exposes the API, and now you're ready to query it. And this makes it easier to scale. Postgres is going to scale with you. You can also use this to join on-chain and off-chain data. There are multiple ways here. So we have a proposal to have Substreams support off-chain data, and for example, bringing IPFS data. So in that case, you would have two streams running in parallel, loading into the same database. You can yourself bring your data to that Postgres instance. So you could also push data directly there. So multiple ways where it can make it a lot easier to join on-chain and off-chain data. And so at a high level, really the goal is to continue to build data services that are deployable as deployable units. So what we call the Substreams stream, which is what you know as Substreams. So you have a real-time app that's going to consume the data from the stream. You're writing your transformations in Rust. You consume the data through gRPC in any language that you want. So you have the best performance of Substreams here. You can have webhooks where you just have a serverless backend and we send data through HTTP. SQL analytics for dashboards, for analytics queries. Great if you want to bring some of your transformation into SQL. Substreams SQL in real time, which manages the backend for you, as I was mentioning. If you have a DApp that relies on real-time data and you don't want to have to write all of that backend yourself. And obviously, like subgraphs are also a great solution that brings a lot of tooling, verification, arbitration, time traversal. So a lot more control or a lot more tooling and work that has been done to make all of this possible. So here, depending on what's needed, people can use can pick and choose what's the best for their own use case. And all of that, the goal, like right now, we're at the stage where we're deploying it on our own infrastructure, but we're working with other indexers to have them run it. And eventually the plan is to take this to the network. So all of those data services would be available on the network. And the same model would apply to more data services as we're adding more, not only Substreams-based data services. Bam! Next, we have a demo. This has been a lot of slides, but let's see how it works. I'll stop sharing.
Let's give the control to Steph there. If we have questions,
yeah,
come on.
There you go.
All right.
You might need to zoom in a little bit, Steph.
Yeah. Just
Thanks.
so I can talk with the correct mic. Okay. So typically, I'm just showing you a little bit how it looks like. Oh, it's not centered right. No, it's just that screen. Oh, it's our screen. Okay, so it's good. So typically, you have this little. This has it's like a code gen simple substreams with the SQL definition in it. So it looks like this is a substreams manifest. Okay, pretty simple map events db out. So the db out is the one that goes inside a SQL database. It's just a type output proto sync database. So this is the standard way of defining a substreams output that will go inside a database. This is how we defined that this is a deployable unit. So this is all the info so that it can be deployed by anyone. We know the network and you know which of the modules you want to output. In this case, it's the db out. The type, so it's in this case a SQL v1 service. You have a link to this schema SQL file. It's just like this, create table and blah, blah, blah. This is from the board 8 contract. And you have engine Postgres file front end true. So that's it. That's enough to define a substream. So earlier today, I did the substreams deploy command like this. Also, I can pack it, and all of the info in the schema all goes inside of SPKG file. So it's it's really this file can be shared, and it represents a version of the deployable unit. And when you deploy, you get this information. Typically, deployment ID, sync status is available here, so you get this little service that answers which is the last block that was processed. And you see, since it's a development environment with a concept of development or production, development, you get all the access. Also right now for analytics purpose, you can get those access, but because we're just getting the password in plain text, we reserve for development work. So you could connect your data grip or any tool to this this endpoint here, or you could use PG Web as a simple way to see what's going on. Oh, you see, data is in there from the board 8. So this is basically you wrote or you generated or you took the substreams from substreams.dev. You add the little sync information that you say, oh, SQL with PostGraph file or without PostGraph file, development or production. You just bundle this and send this to the deploy StreamingFast.io or another indexer endpoint. And you get all this, the indexation is done, and you get the data in there. I have another little example here where it's CryptoPunks in ClickHouse variant. So the difference here, engine is ClickHouse, and we have enabled the REST front end because we can't have PostGraph file on a ClickHouse. It's currently not supported. So deploying this gave me this different version of message saying, sync status again, development environment, and there's a REST to SQL interface. That's a thing that guys from Semiotic wrote, a little SQL wrapper. So I just come here. Actually, I had it open already. Oh, yes. So I have it here, and you can, just push a little SQL injection here, and you get the result. Basically, you could replace this little injection widget by the LLM or any cool feature that would transform into a SQL query directly to this kind of hosted deployed front end. Yeah.
Boom. I hope there are questions. You put them in the channel there. We have, we put the one slide there.
Yeah, we have one last slide. How do I go back here?
That's very cool, guys.
Just switching. You're seeing the slides, right?
Yeah. Mm-hmm.
All right. Yeah, go ahead.
You go. No, you. Wait, you do that first.
So yeah, like just to summarize, so now we have like a new solution to deploy data services, and we're starting with SQL backed by Substreams, but this is really just a first stepping stone to get more data services to the network and make them easier to being deployed. So right now it's available in beta. We have a tutorial. We have the link here. We'll be sharing it also after with everyone in the chat. So try the tutorial. Send your feedback. Really looking forward to having more people put their eyes on it and starting to use it with their use case, bringing their own substreams, bringing their own SQL transformation. And really what we're building towards is like having a complete dev workflow where you can discover substreams through the registry in substreams.dev, then build them either directly in Rust like people have done, but building more code generation modules, bringing new multi-language support so that more people can contribute and build substreams in whatever programming language they prefer, and then deploy them through the deploy unit. So really like finding substreams, building, customizing them potentially, and then deploying and making that flow as simple as possible. Potentially someone that's like even not a developer could do all of these steps, right? Like find a substream that's available, deploy it, and everything's ready. And I'll let Alex conclude with the next steps, what we're looking at the moment and we're going to be working on.
Some of it is just named there, the complete dev workflow, like next languages is some things we're going to be working on, but also we're thinking of bringing in other data services of the type, let's say an endpoint for one SAT Bitcoin ordinals. And do I announce that right now? That we have a Bitcoin implementation live. So Firehose for BTC is fully synced, and so maybe just insert that into the mix. So that means that we also want to offer new services. Yes, Firehose Substreams, but also other things. Namely, you mentioned it a bit earlier, IPFS stuff. Maybe it's useful to have the IPFS being deployed. Also a thing to extract data from IPFS, another different source than Substreams. And when thinking Bitcoin ordinals, it's a different endpoint, maybe a different service. And we want to bring a lot of data services. Think also JSON RPC for the different chains. And so we'll be working out to be able to declare more types of services, and also to allow people to define a little bit more of their resource usage, maybe size of databases, the type of access they want, the sort of privacy they want. Is that a public thing that anyone can access? But if you're going to write some information, maybe we want to have it a bit more private. All these becoming an option on the Graph network. And obviously this is the first stab at it, but packaging all of that in a way so that indexers in this audience and everywhere can run these elements in a sustainable way and provide that service, which it gets a little bit more complex, a little bit more involved, but provides service that is on the edge, that is on delivering what people want right now. As the new needs come over, as the new offerings come on the table, we can be there and adapt to. So try the tutorial there. We want your feedback on all the things, and if there's any questions, we're going to take them.
Yes, thank you, StreamingFast team. We do have a question from Christoph, I believe Playgrounds Network. Christoph is asking, maybe I missed this, but is it currently possible to deploy all of this to local infra, or do we have to use StreamingFast infra?
So
I responded in chat. Yep.
All that you've seen is you've seen the -E on Stefan's machine deployed on StreamingFast.io. Well, if you don't put that, you can run sync a service local. You can serve a small shim that's going to do all of that on your own machine within a Docker Compose environment. So all you need is Docker, and all of that will work locally for a dev environment. And then you turn around to a sophisticated provider elsewhere, and they're going to go do the production for you. So yes, it is our goal that we provide a dev environment for all these things that may seem more complex, but you'll have a version that works full-blown locally, and that you can deploy the same thing, same unit on major, providers out there.
Christoph and Tashi, feel free to. Yeah, that is pretty awesome. Christoph says you guys can use the mic if you wanna ask questions. We have Tashi, you have Christoph, and Thierry. The whole team is here. Interesting. Very cool. All right, questions, folks.
Yeah, I have one. How does that work with DBT exactly? Like it's in one of the slides there was an arrow from the DBT towards the ClickHouse /Postgres
Well, DBT literally gets deployed in the package. It takes your models in a zip file, packages it on, sends it over, and the remote service will run DBT on a period and a frequency that you decide. So it just sends it over. You can do local development by configuring your local DBT environment to point to the database. If you look at the tutorial there, you should see there. And there's Substreams SQL, is that the right one where we include DBT?
Yes, it's mentioned in the tutorial.
So you should be able to do that there.
Typically in a development mode, when you deploy with the default flag is development, it will not run DBT for you because typically you want to develop your own models, work on them, iterate, apply to the recipe. But there's two ways of using DBT. One is to just define some schemas, define some tables, some views, and just apply it and then be done. But there's also like a recurrent ways where every time the DBT runs, it will create new models by updating a table or updating a materialized view or stuff like that. So if you use it this way in a production mode, you just specify in the manifest the frequency in seconds, how many seconds between each runs of DBT to keep the data consistent.
So if your query time aggregation is fast enough, you can keep it real time in a view. If it crunches a lot of data, you'll want to make it periodic so that your queries can be fast. And the crunching doesn't happen when the query arrives. So these are the different flip sides of when using DBT. The compromise between latency and the work you need to do. You figure that out.
Perfect. Thank you.
Thank you, Thierry. Here's a chocolate bar.
I pasted the link to this tutorial in the chat, and I'll paste it in our show notes and the forum too.
I have
It's pretty
another
comprehensive
question.
and simple. Right, let's go.
Yeah, so so following up on my local versus cloud infra, is it possible to deploy like some of these units to some cloud provider like StreamingFast, but then have the database be hosted somewhere else?
Your question is whether you can run some things locally and have the database run remotely?
Or vice versa. Let's say like I have, a database in in our cloud, but out of like that whole package of deployable units, I want everything else to be run on, say, StreamingFast infrastructure, but then it pushes the data to my database.
So that's a very interesting use case. I'd like to go through that maybe with you separately, because we definitely want to address, and we've seen people with all sorts of wonky needs, and we can imagine someone running a blockchain business. They have built some stuff. There are some constraints that are of different nature, privacy, and then maybe you want to control some more. And I had someone who told me, I want to manage the auto scaling because at night I get much less requests. I don't want to pay for that. Will you guys offer that? So my goal is to be able to express these things, these needs, and have the deployable offering and be able to answer these things. So why not eventually, if you can declare that you want to sync, and then you'd be able to specify what that database is, you give it a Postgres access to some place that is at your place, why not? Why not be able to express that? We can discuss that and come up with some interesting solutions there. This is the first iteration that we're showing to get you guys accustomed to that. There's a new product. SQL becomes part of the network, and we're starting to the first deployable stuff because we want as fast as possible to wire it into the graph network so people can start offering these things, and we can start having query fees for that. The network bolsters in use and new use cases and volume and whatnot. Does that make sense?
Yeah, that makes sense. Thanks.
Amazing. Thanks for joining, Playgrounds team. Thanks for joining and asking questions. Super helpful. I'm glad you like it. We're at the top of the hour, so last minute, folks, questions. The chat is open. Most people here can also talk, so feel free to. I see some indexers, so I'd be curious to know what they think of this stack. All right, no questions, no comments for now. I guess we'll just keep on grinding. And
so everyone, we
very
very
cool.
much like, if you want to send comments, please come to either our Discord or send some message, I don't know, and tweet some about it. We want to hear from you, from minute details to the large picture. Thank you.
We have a question, Marc-Andre. I'm not sure, an indexer. I'm not sure I understand. Very cool. Looking forward to understand how it will fit with WDS. It might be me, but what is WDS? Can we address this before we go?
This is World of Data Service.
Oh, okay.
Yeah.
You guys have
World
acronyms
of
now.
Data Services and how it's going to fit in the tokenomics of the project or the network and all these things. That's very cool stuff, very promising. It's extremely exciting to see all these developments. But yeah, as an indexer, I want to know how I'm going to be able to run these in the future and how the network will support that. But I understand that's coming.
So there's two places. There's the work being done so that this exists, and then there's the token economics. We're going to wire it in. There's different efforts from different parties here. So what we're presenting is really the concrete, sort of what you can deploy. Obviously, some other folks and us are working to make that tie up to the token economics. And the way you'll be able to run that, hopefully, like the Substreams, as we said, runs locally. You'll have a complete snapshot of what you can do directly in the binary. And then we might provide some, tools around to ease that if you want to run that, I don't know, using Ansible, Bash script, systemd, or Kubernetes here and there. We're going to slowly but surely bring a little bit more, meat around that to help folks bootstrap. But you'll always have a reference implementation as the development environment, which is going to work and do the whole shebang.
Coming soon, TM. All right, folks, that's it. We're at time. Thanks so much again for all speakers. Thanks for those who joined and asked questions. Always great to hear your feedback. Thanks for joining, and I'll see you in a month. Take care. Bye.